Hello dear students, welcome back to BYJU'S Exam Prep. Now under data structures and algorithms, we are talking about how to think recursively. Okay. Now under this, the last topic is matrix chain multiplication. And this is one of the famous problem which you discuss under dynamic programming. See, let it be dynamic programming. The story is simple, sir. We need to write recurrence relation. The only difference between regular recurrences and recurrences in dynamic programming is the same subproblem is repeated. So instead of solving same subproblem again and again, we store and reuse it. That is the logic behind dynamic programming. I am not going to give you much details about dynamic programming here because within the example you will understand the story. Am I clear? So please let me know how many of you are interested in this particular topic. This is one of the important topic for any level of examination in algorithms course. If you are learning algorithms for college level, for university examination level or competitive examination level or for GATE examination, this is the one of the important topic. Okay. So before starting the topic, let me introduce about myself. Myself Sridhar Dhulipala. I am having 20 plus years of teaching experience. I worked in all famous GATE institutes earlier, and from past 1 year I am associated with BYJU'S, and I am working on a project which is called Recorded GATE content. It is first of its kind and unique type of the content. We created visualized animated content and many teams were involved, and from past 1 year we are working on this particular project. Now under BYJU'S Exam Prep app, under the category Learn with Video Lessons, you can find these videos. I already recorded the following subjects: discrete mathematics, algorithms, engineering mathematics, C programming and data structures. Those who purchase the course can access all these videos. I think C and data structures are about to upload. Okay, they are in the final stage of editing. And remaining all courses are already available in your BYJU'S Exam Prep app, my dear friends, under Learn with Video Lessons category. Am I clear? And my qualifications are given here: MTech Saka from NIT Karnataka Surathkal and MSc Mathematics from JNTU Hyderabad. So this is about me. Now let us start with today's topic, that is matrix chain multiplication. One of the important and of course the easiest topic. So let us try to understand how you get this recurrence relation. Then we try to solve problems. I'll not get into the more details like pseudocode and all because within 1 hour I need to complete the entire story. So what I do is I'll give you the recurrence relation. Okay, we generally call it as dynamic programming formulation. That I'll give you. Then I'll tell you how easily we can solve problems on matrix chain multiplication in this video. Okay, please watch till the end to understand the procedure in a very simplified version. Okay, or simplified manner. Okay, now the general question which they ask you is, they'll give you 3 matrices and they ask you the minimum number of multiplications required to find the product. What product? A into B into C. Hi, in sorting how many problems? Dear students, I am talking about matrix chain multiplication. Towards the end you can ask general questions. Okay, there are many problems are there in sorting. Am I clear? So general sorting techniques will be there. Sorting techniques based on divide and conquer will be there. Sorting technique based on the tree method will be there. So there are many sorting techniques. Am I clear? So let us talk about this. Good evening, very good evening, AB de Villiers, right? Minimum number of multiplications required to find ABC. This is the general question. For this we need to know the following. The number of multiplications, the number of scalar multiplications you can call it. The number of scalar multiplications required to find the product A into B, where A is a P by Q matrix and B is a Q by R matrix. Okay. So what about minimum number of scalar multiplications required to find the product A into B? If you want to find the product A into B, generally under linear algebra I discuss under mathematics. If you know it, fine. Otherwise, please note this as a result, P into Q into R. See, if you want to multiply two matrices A and B, the minimum number of multiplications required is given by, if A is P by Q and B is here Q by R, sir. Q by R, the minimum number of multiplications required is given by P into Q into R. Okay. Now, the question here is, what about the minimum number of multiplications required to find this product A into B into C? First, let us solve it as a general problem. Then we try to see the dynamic programming approach for this. Okay? Okay, de Villiers. Let me continue. Now, how can you multiply three matrices, sir? Directly, you cannot multiply three together. So, for that, we need to do like this. Either you can do first A into B, then the result can be multiplied with C, or first you can multiply BC, on the left of that you can multiply A. Am I clear? Now, if you multiply AB here, how many multiplications are required? Because A is a 3 by 2 matrix and B is 2 by 5 matrix. If you want to multiply AB, how many multiplications required? How many multiplications required? 3 into 2 into 5. 3 to 6, 6 5 30 multiplications are required. Suppose the answer for this is, say, some D matrix. We do not know, no? So I just given some D matrix. Now this result to be multiplied. What about the order of this D? If A is 3 by 2 and B is 2 by 5, the order of this D will be 3 by 5 matrix. This is 3 by 5 matrix. And C, we already know it is 5 by 4. Now this result to be multiplied with C. And how many multiplications are required for this? For this, how many multiplications are required? To multiply these two matrices, how many multiplications required? Okay, so the answer for that is 3 into 5, 15 into 4, 60. Am I clear? So here it is 30 and here it is 60. Total 90 scalar multiplications are required. Then you are going to get the solution matrix, my dear friend. And solution is of order 3 by 4. And the solution matrix you can get by using 90 scalar multiplications. Wonderful, Ishan. Wonderful, very good. If I use this order of multiplications, I require 90 scalar multiplications. Am I clear? Good. And before continuing further, I'll tell you one important point here. Please remember, because towards the derivation of the recurrence relation, these points will be very, very useful. Here it is 3 by 2. Then B is 2 by 5 matrix. Then C is 5 by 4 matrix. If you multiply these three matrices in any order, the final resultant matrix order will be this row number into this column number. This is 3 by 4. Please remember. Even if you multiply 10 matrices, the resultant matrix order will be first matrix row number into last matrix column number. Please remember this. I use this idea later on. Please remember this. Am I clear? Very good. Now, what if I multiply them in this order? Because I can multiply ABC in this order also. If I multiply in this order, what about the number of scalar multiplications? Here, first of all, I have to multiply B with C. B is a 2 by 5 matrix and C is a 5 by 4 matrix. 2 by 5 into 5 by 4. How many multiplications are required? Here I am writing multiplications. How many multiplications required? 2 5s 10, 10 4s 40 multiplications are required. Suppose this answer is, say, some E matrix. What about the order of E? Because 2 by 5 into 5 by 4 means the order of E will be 2 by 4 matrix. Very good, very good. Good. Perfect. Yeah. See, I'm just trying to get into that main idea, so I'm just giving you this basic idea quickly. Okay? Very good. You are giving wonderful answer, A.B. de Villiers. Good? Right. 3 by 4 is perfect answer. Now, this need to be multiplied with A on left. A is of order 3 by 2. Now, if you multiply, you are going to get the final solution matrix. You have to multiply these two, then you are going to get final solution matrix. What is the order of this solution? The order of this solution is obviously 3 by 4. But to multiply A with E, how many multiplications required? To multiply A with E, how many multiplications are required? Anyone want to answer this? Yeah, very good. So, as my friend suggests, 24 multiplications are required, because 3 into 2, I think it should be 2 into 4. 3 into 2, 6, 6 4 is 24. So 24 multiplications are required. So 40 plus 24 is 64 scalar multiplications. That is, you could able to get the solution matrix with just 64 multiplications. You are not using 90 scalar multiplications, just using 64 scalar multiplications, you are able to find the product. Am I clear? So the minimum number of scalar multiplications, or simply minimum number of multiplications, because you understand by multiplication we mean scalar multiplications only. You can simply say minimum number of multiplications is equal to what? 64. And can I use this order, or I can only use this order? Okay, I got minimum number of scalar multiplication, but my doubt is, can I use that order for getting A into B into C? Is there any result which support me? Is there any result which support me that I can do by this order also? What is that result? Yeah, 64 is minimum, wonderful. Is there any result which support me? I can do both the orders, fine. Any order you do it, and you can take whatever is the minimum that you can take. There should be some result which should support me. What is that result which support me? The result which support me is associative property. Matrix multiplication is associative. Whether you do left to right multiplication or right to left multiplication, the answer is same. Because of this property, matrix multiplication is associative. I can take any order, and in that order, whatever order gives me minimum number of scalar multiplications, I can select it. And because of this property, this is the heart of this problem, sir. What is the heart of this matrix chain multiplication? Matrix multiplication is associative. Because of that, I can select the ordering which gives me minimum number of scalar multiplications. Am I clear? So that is the idea. Now, don't worry, we'll learn how to solve it. I'll directly give you. Now, when you are having 4 matrices, what are the different orders in which we can multiply? Of course, the question is same, minimum number of multiplications required. That is the question. We'll solve the same problem later on using dynamic programming approach. But first, I'll give you the solution. Am I clear? See, we need to find all possible orderings of multiplying these matrices. So you can multiply these matrices in this order: second order, third order, fourth order, fifth order. Actually, there is a result. The number of multiplication orderings for n plus 1 matrices. How many multiplication orderings are possible? Very good, ABDVS. Very good. Yeah. How many multiplication orderings are possible for n plus 1 matrices? If you are having n plus 1 matrices, how many multiplication orders are possible? If you are having n plus 1 matrices, how many multiplication orderings are possible? Can anyone tell me that? See, this topic is important for any level of examination. Let it be college level or gate level or any competitive level. This is one of the important problem, my dear friends. Okay? NC2 is wrong answer. Don't worry. Very good attempt. And that is given by Cn, where Cn is called Catalan number. What is it? Catalan number. The number of multiplication orderings for n plus 1 matrices is given by formula Cn, where Cn is Catalan number. And Catalan number is given by formula 1 by n plus 1 2n Cn. There is a formula, sir. Catalan number we call it. What is it called? Catalan number. One of the very, very beautiful problem. And in discrete mathematics, data structures, in algorithms, you use this Catalan numbers many times. Okay? You use this number many times in these 3 courses, my dear friends. And almost there are 64 plus problems for which the solution is Catalan number. Am I clear? So sometimes we'll try to discuss this in more detail, my dear friends. Okay. So actually when you are having four matrices, n plus 1 is 4, no? Then the number of multiplications or multiplication orderings possible will be C3, where C3 is given by 1 by 3 plus 1. That is 4, 2n, 6C2, and which is 5. And these are the 5 orderings, my dear friends. And if you multiply in these orderings, I'll just give you the answer. We'll later on check it, sir. If you go by first ordering, we require 11,500 scalar multiplication. Second order requires 65,000 scalar multiplication. Third order requires 1,25,000 scalar multiplication. Fourth order requires 23,000 scalar multiplications. And you know the last order requires how many scalar multiplications? Just 2.2k. Just 2,200 scalar multiplications you can multiply these 4 matrices. And that is the idea for using best ordering. And how to get the best ordering we try to understand. And for that, first we try to create the dynamic programming formulation. See, my dear friend, when you say dynamic programming formulation, it is very simple, sir. We are writing recurrence relation. We write recurrence relation, and in that recurrence relation, same sub-problem is solved many times. So instead of solving it again and again, we store and reuse it. That is the dynamic programming, nothing more than that. They may use different terminologies, but dynamic programming means this one. Write the recurrence relation. In that, same sub-problem is solved many times. So instead of solving it, store it and reuse it. Store it and reuse it. Am I clear? So this is the idea of dynamic programming. Am I clear? Catalan number sub place mein aata hai. Yes, sir. Very good. Okay. Now let us see the matrix chain multiplication problem. What is this matrix chain multiplication problem? Consider the problem of multiplying n matrices together. That is, you want to multiply these n matrices, m1, m2 and so on, mn. And the product is, let us suppose m is the product. And here we are assuming this for simplicity. We assume that m1 is of order r0 by r1. m2 is of order r1 by r2. m3 is of order r2 by r3. So similarly, mi matrix is of order ri minus 1 by ri. That is what we are assuming. That is order of each matrix. For each matrix, we will be having order, number of rows and number of columns. So let us assume that each of these matrices is having some orders like r0 by r1 for m1, r1 by r2 for m2, and continuing this way, last matrix, that is mn matrix, will have order rn minus 1 by rn. We assume this orderings for each of these matrices. Now what we need to do, sir, we need to find this m1n. We need to find this m1n. That is what we need to find, and this is the notation I am using. And what is this notation means? The minimum cost of computing m1 to m1. That is for finding this product. The minimum number of scalar multiplications required is given by this m1n, my dear friends. So that is, what is this m1n? It is the minimum number of scalar multiplications required to find this product of n matrices. That is the notation we are using. Am I clear? That is the notation we are using. Now I am going to create a recurrence relation for, of course, not for m1n. m1n is the last solution, final solution. I try to create a recurrence relation for a sub-problem. That is, in between, suppose from mi matrix to mj matrix, if you multiply, for that, how many multiplications required? Sorry. Sorry. mi to mj, how many multiplications are required? For that, I write the recurrence relation, and that sub-problem can be used to solve the main problem, that is this m1n. Okay, so let me create that sub-problem, sir. See, mij. See, m1n means what, sir? The minimum number of scalar multiplications required to multiply matrix from m1 to mn. So what is mij? Minimum number of scalar multiplications required to multiply matrix from mi, that is mith matrix to mjth matrix. How many multiplications are required? This mij going to give you. And we are going to write recurrence relation for this. If you understand, you will never forget the formula for matrix chain multiplication. That is the recursive formula. This recursive formula is what we call it as dynamic programming formulation, my dear friend. Nothing more than that. Just we need to express this in terms of subproblems. Just we need to express this in terms of some problems. Now look here, sir. Suppose I am going from say M3, M4, M5, M6. To get the minimum number of multiplications, either first you need to do this or you need to do this or you need to do this. Correct or not? First you have to cut somewhere. And after cutting, how this problem is solved, that is taken care by recursion. You don't have to worry about. See, when you are writing problem in terms of subproblem, just express problem in terms of subproblem. How subproblem is expressed, it will take care of same story. It will be done in the same idea, my dear friends, because it also expressed in terms of its subproblems. Am I clear? Number of matrices between I and J is J. Okay, that is not very important here. Don't worry. ABD leaders, very good. That's good. But that is not very important here. Okay. Okay. So we need to know if you are finding this Mi to Mj for minimum number of scalar multiplication, somewhere you divide. For example, in the example which we take in ABCD, the minimum number of multiplications are obtained by dividing like this. But for this, first of all, you have to divide it ABC. This is where you have to cut. So that is what? The cost of breaking the product at that particular MK matrix, first you should know. Once you know, this is one subproblem and this is one subproblem. And these two subproblems can be solved recursively. These two subproblems can be solved recursively. First thing which we need to do is, this original problem, that is Mi to Mj, we need to cut at Mk. But this K, you know it. Where to cut, you know it. We do not know. Assume that, first of all, let us assume that we know it. Let us assume that we know it. Don't worry. I'll tell you how you can find exact K also. For time being, let us assume that you know what is that K. Let us assume that we know that K. So, if you want to find this product Mi to Mj, assume that you know K. Where to cut, you know it. And if you cut at this K, you assume that you are going to get minimum number of multiplications. We do not know K, but assume that we know K. Am I clear? So, this subproblem multiplied by this subproblem will give you this minimum number of scalar multiplication for this problem. Because this subproblem is also solved for minimum number of scalar multiplication. And this subproblem is also solved for minimum number of scalar multiplications. Both are solved for minimum number of scalar multiplications. And if these two subproblems are multiplied together, then you are going to get minimum number of scalar multiplications for the original problem. Am I clear? Yeah, that's what I am going to tell you, sir. Don't worry. Don't be in a hurry, sir. That is the main aim. That is what we are learning. How to find K, I am telling you. How to find K, I am telling you. That is the main idea. If you understand, the recurrence is done. So we do not know K, so let us assume some arbitrary K. And what can be K, let us see later on. First, assume that some K is there I could able to cut it. Now, you need to multiply this matrix and this matrix together to get the original matrix. Now, this is a subproblem. See, what is the cost of this, sir? We already said cost of this is Mij. Then what is the cost of this problem? This cost is Mik. And what is the cost of this problem? The cost of this problem is Mkj. So, minimum number of multiplications required for this is Mik. Minimum number of multiplications required for this is Mkj. You need to add these two because this multiplications plus this multiplications followed by what? After getting these two solutions, we need to multiply these two matrices. Am I clear? See, if you multiply, this is some matrix A. If you multiply all this is some matrix, say D. You have to multiply these two. Again, we need to know how many multiplications are required for multiplying A into D. Now, please tell me what is the order of A and what is the order of D. See here, you are multiplying Mi to Mk. Mi is of order what? Ri minus 1 to Ri. That is Ri minus 1 cross Ri. And what is the last matrix? Mk. What is the order of Mk? Order of Mk is Rk minus 1 by Rk. So if you multiply these two all these matrices, the resultant matrix order will be, I already told you, first matrix row number, that is Ri minus 1, into last matrix column number, that is Rk. Got it? Last matrix column number. फर्स्ट मैट्रिक्स रो नंबर कितना है, RI माइनस 1, एंड लास्ट मैट्रिक्स रो नंबर कितना है, कॉलम नंबर कितना है, RK. First matrix row number and last matrix column number. So you know the matrix A's number of rows and number of columns. Now similarly for D, what about the order of D? See here it is going from MK plus 1 to MJ. MK plus 1 का order क्या है? Sorry. What is the MK plus 1 order? RK plus 1. And last matrix order कितना है? RJ minus 1 RJ. Now what about the order of this product? What about the order of this product? Order of this product is first matrix row number into last matrix column number. That is simply RK cross RG. And you know A and you know D. And you remember the first formula. If A is P by Q matrix and B is Q by R matrix, minimum number of scalar multiplication is given by P into Q into R. So similarly here A is of order Ri minus 1 by Rk and D is of order Rk cross Rj. Then the minimum number of multiplications required to multiply these two matrices will be Ri minus 1 into Rk into Rj. And that is exactly this one. Ri minus 1 into Rk into Rj. And that is the answer, my dear friends. So if you know where to cut the matrix, then you know minimum number of scalar multiplications for this matrix. You know where to cut, then you know minimum number of scalar multiplications required for this particular matrix Mij. So the value of Mij will be, because you are cutting at K, no, I to J, what will be the answer? Mik. K plus 1 to J, what is the answer? Mk plus 1J. Because Mk plus 1J is minimum number of multiplications required to multiply those matrices. But after these two, we have to multiply these two matrices. And for that, how many scalar multiplications required? We require this many scalar multiplications. And that is nothing but Ri minus 1 into Rk into Rj. Am I clear? Very good, very good. Perfect, De Villiers. You are following perfectly and you are writing the answers super fast. Very good. I like that. Super. You understand? And here we assume that K is known. But do you know K? You know K? No. As A.B. De Villiers asked me, how to find K? That is the point we are going to address now. If you know K, then you know the solution. If you know the K, then you know the solution. But you don't know the K. You don't know the K. Am I clear? So what I should do? Okay? So try all possible Ks. Because you don't know K, right? Try all possible Ks. And in that, take the K which gives you minimum value. Take the K which gives you minimum value. Got it? So here, see when you are going like, M1, M2, M3, M4, you can cut here. So you can cut at M1 or you can cut at M2 or you can cut at M3. So K can be 1, K can be 2, K can be 3. That is, you are going from 1 to 4, K value can be 1, 2, 3. K value can be, hi Venkateshwarlu, K can be 1, 2, 3 if you are going from 1 to 4. Similarly, if you are going from I to J, what can be K value? See, 1 to 4 if you are going, K value can be 1, 2, 3. If you are going from I to J, what can be the value of K? What are the possible values of K? Hi Venkateshwar. K value can be what, sir? K value I से J जब जा रहे हो, I to J if you are going, K value can be starting from I to J minus 1. except j, remaining all values k can take. So you try to take all possible values of k. In that, whatever gives you minimum, take that k. And that is the result. See here, mk plus 1j, I minus 1, rk, rj, where k varies from where to where? K can be I plus 1 up to j minus 1. That is what in short notation how we write. The k value can be I. Here I written equal to and it go up to j. It go up to j. Less than j, not equal. No equal to here. Only less than j I written. Is the result clear? So that is the idea. Am I clear? See, I'll just quickly recap what we done. See, to find Mij, you need to know where to cut. You do not know where to cut. So let us assume that you cut at k. So if you cut at k, the left problem cost will be Mik and the right problem cost would be Mk plus 1j. But the left and right to be multiplied together. So how many multiplications required to multiply the left and right? That is given by Ri minus 1 into Rk into Rj. But you do not know k. So what you do is you try to take minimum among all the k's. That is, you find for every k, in that you take minimum value. And what are the possible values of k? The possible values of k can be anything from I to j minus 1. Anything from I to j minus 1. And that is how we get this particular formula, my dear friends. And whenever you write recurrence relation, we should have base condition. The base condition happens when I is equal to j. That is, when you have single matrix, number of multiplications required will be 0. So we should have 2 or more matrices, then we can use this formula, my dear friends. Then we can use this formula. And that is the recurrence relation, my dear friends. And that is the recurrence relation. And I written the dynamic programming formulation for matrix chain multiplication. I'll just quickly write down how to remember this. Mij value will be, how you remember? When I is equal to j, that is when you have a single matrix, no multiplications are required. When I is not equal to j, I'll write it down. I is not equal to j and j should be greater than 1. J should be greater than I. That is, index j must be more than I. So mi to mj you want to multiply. So you assume that somewhere you cut at mk. So if you cut at mk, up to here what is the cost? Mik. And from here to till end what is the cost? Mk plus 1 to j. But after getting these two solutions, you have to multiply. So how many multiplications required for multiplying these two matrices? Because the resultant matrix order will be Ri minus 1 by Rk. This resultant matrix order will be Rk cross Rj. So number of multiplications required for multiplying these two matrices will be Ri minus 1 Rk into Rj. But here we are assuming that we know k, but you do not know k. Therefore, what we have to do? We have to find for all possible k. And what are the possible k from mi to mj, sir? I plus 1 up to j minus 1. So you have to find for all possible values of k starting from I till less than j. And that is the total recurrence relation, my dear friends. Hope you understand. And that is the recurrence formula for matrix chain multiplication. See, if you do not understand this recurrence formula, blindly you note it as a formula, it's of no use, sir. The basic idea of dynamic programming is first you have to know how you get the recurrence relation. Then you should know how to solve the problem using the recurrence relation. Now we move on to the second stage. The first stage is completed. Any doubts, please do ask me, sir. Please do ask me if you have any doubts. So now I'll teach you how to solve problem using the recurrence relation. For that also I'll try to give you the simple techniques. How you can quickly solve the problem, I'll tell you now. See carefully. If you have any doubts, please ask me, sir. I created the recurrence relation. Am I clear? And ultimately what we have to find, sir? M1n we have to find. Mij is intermediate problem or a sub problem, but I need to solve M1n because M1 to Mn I have to multiply. This would be my original solution, sir. So using this intermediate solutions or solution for intermediate subproblems, I need to create solution for my original problem. Is the idea clear? All of you able to follow? Hope you are all following, sir. Yeah, good. Now let me explain how to solve problem using this recurrence formula. See, once you own the recurrence relation, no, then you don't have to worry, sir. Automatic, rest of the things follows automatically. But I'll give you the best method, quick method to solve matrix chain multiplication problem. See carefully. Yeah, I am solving, sir. AB de Villiers, I am solving according to the formula only. Without using formula, you don't solve it, sir. We have to use it. Am I clear? And I tell you why it is dynamic programming. Okay, see, the complete details I may not able to give because I am giving you the method completely, but you will understand how to solve problem. I may be explaining with 4 by 4, but you can solve 5 by 5, 6 by 6 also using the method which I am giving you. Please see carefully. Now, if you want to solve the problem, we need to create what is known as lookup table. What is it called? Lookup table. And actually, they create two tables. If you want to multiply M1 to Mn, they actually create two tables. One is n by n matrix and the other one they create is n minus 1 by n minus 1. But within this table, we try to create both. Within this table, we try to create both. Okay. Now look here. How to write the numbers? 1, 2 and okay, here it is 6 by 6 example I given. So let us assume that n is equal to 6 for simplicity. So here it is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is what we call it as M table. Okay. M table will give you the minimum number of scalar multiplications, but it will not give you where to cut. It will only give you final answer, but it will not tell you how to cut it. And for that we need S table. S table tells you where to cut, what is the K, and that is the order of multiplication is obtained using S table. And for S table, we need only n minus 1 by n minus 1 matrix. And I am not going to write separately, sir. Within this matrix, you just see from here, this matrix. The red one is your n minus 1 by n minus 1 table. See, actually, M table varies from 1 by n, that is 1 to n. That is, I values vary from 1 to n and j value varies from 1 to n. Whereas S table, I values varies from 1 to n minus 1, but j values vary from 2 to n. That is n minus 1 by n minus 1 table, sir. Am I clear? So please remember these two tables because these two tables are very, very important. And I'll tell you within one table how to write S values as well as Mij values very quickly. If you understand this, any problem you solve just like this. Okay? See this. Okay? Now, of course, this formula again same thing. Mij will be 0 for I is equal to j. See, my dear friends, I'll just remove this red part so that I can explain this better. See here, this main diagonal values will be 0. Why, sir? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. That is Mij. I is equal to j, then the value is 0. We require 0 multiplications. So the story is to fill above this main diagonal only. Below this you don't need, sir. All this is not required. Sometimes people write only this above diagonal matrix, only they write it. But for clarity purpose, please write down the complete table so that it will be easy for you. First fill the main diagonals, that is 0, 0, 0, 0, 0. And from here onwards, how to fill it. Now look here, sir. If you see this main diagonal, that is matrix of length 1. If you see the next diagonal, here you are going to get matrix of length 2. That is product of length 2. Product of length 2 you are going to get. And this next diagonal, if you see product of length 3. That is multiplication of 3 matrices. For that, what about minimum number of multiplications you are going to get? The next diagonal, if you see product of, that is minimum number of multiplications required to find product of 4 matrices, you will get it. And it is for length 5 and this one is for length 6. If it is a 6 by 6 matrix. Am I clear? So we are going to fill this matrix or fill these tables diagonally. First length 0, that is directly available. Then we fill length 1, then we fill length 2, then we fill length 3, then we fill length 4, then we fill length 5 and finally we fill this one, that is length 6. If it is 6 by 6 matrix. Okay. So now let me explain with one example. Okay. It's very simple, sir. Please don't in between say something. If you have any answer, if I ask something, please answer. Okay? Because I'm trying to explain a very, very simple method for solving this matrix chain multiplication problem. Of course, using the same formula. What is our formula? You should remember that. Mij is equal to 0 for I is equal to j, and it is equal to minimum I less than or equal to k less than j. Of course, I am not going to use this formula, my dear friends. Even this I'll give you simple method for, solving this problem without properly using the formula. That also I'll tell you. Okay, but one should know the formula. Mik plus mk plus 1j plus Ri minus 1 Rk Rj. This is when I is not equal to j and j greater than I. Now, let us complete it. Now, first I'll take length 0. Length 0 means this main diagonal. You fill them directly. Because one matrix is there. Only first matrix is there. How many multiplications required? 0. Only second matrix is there. How many multiplications required? 0. So, the main diagonal is filled. Main diagonal is filled. Now, see carefully. The length 0 is completed. So, directly all zeros. Now comes length 1. See, we are going to fill like this. First length 0, then length 1 you are going to fill, then length 2 you are going to fill, finally you are going to fill length 3. Okay? And this length 3, this is your M14 is your final answer. M14 is your final answer. Okay? Now, actually within the table, this is your S table. But again, if you write S table, it will be confusing. So what I do, I write the values of S table within the corners like this. Here I am going to write the values of S table. Am I clear? So everything is within this table, sir. Everything can be completed within this table. Am I clear? Clear. So let me clear this. Now see this carefully. Length, sorry, it is, I did mistake, sir. It is length 1, it is length 2. I made a mistake. Sorry. This is length 1, length 2 means 2 matrices, length 3 and this is length 4. Am I clear? Length 2, that is 2 matrices I need to multiply. Now here, what is very important is, when you take this matrix A 10 by 20, B 20 by 50 and C 50 by 1 and D 1 by 100, we just need this R0 value. This is R0 which is 10, R1 is 20, R2 is 50, R3 is 1 and R4 is 100. These values you have to keep track. Because our formula is in terms of this Ri's. So I am just identifying what is this Ri. Am I clear? What is this Ri I mentioned? Now let us see this length 2, my dear friends, carefully. See this carefully. Length 2. See, length 2 is simply these two, if you multiply, how many multiplications are there? These two, if you multiply, how many multiplications are there? These two, if you multiply, how many multiplications are there? And for length 2, only 1k value will be there. See, if it is M1 to M4, 3k values are required. But for 2 multiplications, only 1k. Because AB are there, that is where you can cut. Am I clear? So, direct answer you are going to get. So, directly you have to multiply AB, BC, CD for this. Directly you have to multiply AB, BC, CD. Am I clear? So, before the values are all zeros. Okay. Now, let us see in the diagram. We are filling these values, sir. This one, and this one. We are filling these 3 values. Okay. Now, let me start with 1, 1. What is this M12? Now, look here. See this very carefully. Left side only 1 value, below only 1 value. Add these 2 fellows. If you go for formula, it is your M11 plus M22. This is your M11 and this is M22 according to this formula. And those values are simply obtained here and here, sir. That's why I directly written. Am I clear? Plus, now look here. We are going from M1 to 2. See, whenever it is Mij, it is Ri minus 1, Rk, Rj. K varies, this Rk varies, but Ri minus 1 and Rj will be fixed. So for this Ri minus 1, when it is M1 means Ri minus 1 means R0 and last one is R2. These two will be fixed. These two will not change. Only the middle value for K is equal to, because for two matrices K is only one value, that is R1 is only one value. That is the value fixed. Now R0 is 10, R2 is 50. So 10 into 50, 500 multiplied with 20. It may look little silly here, but if you understand, later on the problems becomes very, very easier. Am I clear? Please see carefully. R0, R2, they are fixed. Only the K value will be varying. K value vary from where to where? I to J minus 1. Here only one value of K, that is R1. So if you multiply them, what happens? 0 plus 0. R0 is what, sir? 10. R2 is what? 50. Always fix these two. Then middle value is 20. So if you simplify, what is the answer for this, sir? 2 5 is 10 and 3 zeros. That is 10,000. It is very difficult for me to write. So 10,000, I am writing it as 10K here. What I am writing? 10K. Because only one K value here. Directly, what is the K value here? K is 1. That you write in the main corner, my dear friend. That you write in the main corner. Am I clear? Now, what about next one? M23. M23. This is M23. For this also, now this is completed. For this also, the left side fellow, bottom fellow. So what is it? 0 plus 0. Now it is 2, 3, no. Ri values are fixed. If it is 2, 3 means R1 and last one is R3 and intermediate fellow is R2. R1, R3 fixed, only this value will be changing. So what is it, sir? 0, 0, R1 is what, sir? 20, 51. 20 into 50, so it is 0 plus 0 plus 52. 1000, it is 1000. Am I clear? So it is 1000, that is 1K. All of you able to follow? Is the idea clear? And what is the value of K used? K is 2 used. See, actually for the second diagonal, the values of K are 1, 2, 3, directly same values only. So don't have to worry about this, sir. This is very simple. Directly K values are 2, here it is 3 only. Okay? Just for completeness, I am showing you with the formula. Because as DB de Villiers asked, with the formula how it goes. Now if you want, you can do without the formula also. M34. What is it? M34 means you remove this. Because for this, you just take the leftmost value and this value. So what is the value? 0 plus 0. Now what is it, sir? R2 into R4. R2 means what? 50 into R4, that is 100. And intermediate fellow is 1. 50 into 100 is 5000. 5000K. So this value is 5000. That is 5K I am writing. 1000 I am writing it as K here. Now we completed length 2, my dear friends. Now we need to go for length 3. So here I just kept the values. Now length 3. Okay, we already completed now. So up to here it is completed. It is 10K and it is 1K and it is 5K. This is 1, this is 2 and this is 3. And from here the story becomes very, very interesting. Length 3. For length 3 you see. The first one is this one you have to find. What is that? That is M13. For M13, the possible K values, 2 K values you are going to get. You are going to get 2 K values. See this carefully, sir. See this carefully. See, when you want to find this, the leftmost and the bottom fellow, I am writing it by cross. And this next leftmost and the bottom. These two I denoted by circle. Now look at this. This is 0, the cross one 0 here and here it is 1K. Next one, the circles fellows, that is 10K plus 0. If you want to see what is this, this is nothing but M11 and this is nothing but M23. How? By taking K is equal to 1 you get it. M11, when you take, because K values are, possible K values are 1 and 2. If you take K is equal to 1 you get this sum, and if you get K is equal to 2 you get this sum. And that you don't have to again write the formula and see, sir. If you are finding this particular value, you see the leftmost available value and the bottommost. These two will be one sum. Next, this fellow and this fellow. These two will be the next one. Suppose one more is there. You can denoted by dot dot. These, suppose k values k takes 3 values. This is one value, this is second value, and this is third value. We just need to fill this Ri minus 1 into Rk into Rj. We just need to fill Ri minus 1 into Rk into Rj. But in this case, what happens, sir? K is 2, because length 3 means k can take 2 values. So here we are. This is one value and this is one value. This is crossed values and this is circled values. So this cross value correspond to the first value of k. Circle value correspond to second value of k. Am I clear? So that is how we can identify them easily from the table itself. Now comes the most important point. This is the heart. Now look here. When you are going for M13 with k is equal to 1 or 2. But this, when it is M13, Ri minus 1 means R0. The last value will be R3. Here also R0, R3, this is fixed. These two will be fixed. Only when k is equal to 1, this is R1. When k is equal to 2, this is R2. So here R0 into R3 is fixed. Only we have to fix R1. Only we have to fix R1. Are you able to follow? So what happens to this? This is 0 plus 1k. What is R0? 10. R3, 1. So 10 into 1 is done. Only R1 need to be multiplied. That is 20 need to be multiplied. Next also 10k plus 0. R0, R3 is what, sir? 10. Only R2 to be multiplied. That is 50 to be multiplied. Because these two are always fixed. Only the middle fellow will be changing. That we just need to put. Okay. So when you simplify this, it is 0. 1k plus 200. That is 1.2k. And here it is. Of course, we need to find minimum of these two, sir. Just write down minimum. So what is it? And it is 500, 10.5k. But out of these two, which one is minimum, sir? 1.2k is minimum. So just write down 1.2k. And which value of k is selected? First value or second value? First value of k is selected. And what is the first value of k? 1. So k is equal to 1 here. K is equal to 1 here. Hope you understand. So from diagram, you can identify the result, sir. Now let us fill the next one. Now let us fill the next one. I want to fill this particular fellow. I want to fill this particular fellow. See, for this also, what is that fellow? Actually, M24. I need to find M24. So for M24, see here. Leftmost and immediate bottom fellow. That is 0 plus 5k. Is 1, and the other one I will write circles for them. Okay, this one and this one. That is 1k plus 0. 1k plus 0. So leftmost and immediate bottom, next leftmost and next bottom. Okay, so they'll give you the values for different k. See, this is for k is equal to 2 and k is equal to 3. The first one is for k is equal to 2 and second one is for k is equal to 3. First one is for k is equal to 2 and second one is for k is equal to 3, sir. And now Ri values. What about Ri values, sir? This is R1, R4 are fixed. R1, R4 are fixed. Only here R2 will come and here R3 will come. And what is R1 into R4? R1 into R4 you can already find it. That is 2000. So it is R1 into R4 is 2000 into R2. And here also it is 2000 into R3. R2 is what, sir? 50. And here R3 is 1. Now out of these two, which one is smaller? Out of these two, which one is smaller? This is, okay, 2000 into 50 means, I think it is 10,000, but here it is 2000 only. This is smaller. I am not interested in this. 2000 is smaller. Okay, sorry, 2000 plus 1k, 3000, 3k. So this is 3k, sir. 3k is smaller. And for what value of k? K is 3, it is smaller. So k is equal to 3. Okay, now look here. Now the most important, the last answer. So let me fill all the values which we done so far. This is 0, this is 0, this is 0, and this is 0. And what about this, sir? 10k, 1k, 5k. This is 10k, 1k, and this is 5k. 1, 2, 3. Okay, these values are 1, 2, 3. 1, 2, and 3. Next one. This is 1.2k and 3k. This is 1.2k and this is 3k. And for this k is 1. For this k is 1. And for the next one k is 3. Is the idea clear? Now the most important. See this. We need to find the final answer. That is M14. Minimum of. But in this minimum, see, you want to find M14, right? Total k values, 3 possible k values will be there. That is, k can be either 1, 2 or 3. And for k is equal to 1, the leftmost fellow and immediate bottom fellow. What is it? 0 plus 3k. For k is equal to 2, I'm just denoting by small circle. Circle and this one. That is next leftmost fellow, next bottom fellow. That is 10k plus 5k. 10k plus 5k. If you want, you can use the formula also, sir. You will get it. No problem. For next fellow, I'll just denote some dollar or dot. I'll put dot and dot. That is, what is it? 1.2k plus 0. Now comes, what about this Ri, Rj values? Now here, this value will be R0 and R4. This is fixed every time. R0 into R4 is fixed every time. Only thing is k value will be changing. That is R1, R2, R3. So if you want to write it quickly, minimum of 1, 2, 3. So it is 0 plus 3k. See, R0 into R4, you can find it before only, because for all the fellows we need R0 into R4. That is what? 1000. 1000 into just you need R1 value, sir. And for next one, 10k plus 5k. R0 into R4, 1000 we already know. Just need to multiply R2. Next one is 1.2k plus 0. R0 into R4 is 1000. We already know it. Just need to find R3. First case R1 is what? 20. Second case R2 is what? 50. Third case R3 is what? 1. Don't solve all of them. We need to find minimum fellow. We just need to find minimum fellow. Don't solve all of them. You just identify which one gives you minimum. Which one gives you minimum? Last fellow will give you minimum. That is 2.2k. It gives you. And for what value of k? 3. That's it. 2.2k is the answer. And what about the value of k? See, the third one means k is 3. I got it. See, I written, but I not solved all of them. Don't unnecessarily waste your energy. And this is the best way to solve this problem, sir. Even 5 by 5 matrix also, because here I am explaining, it takes little more time. But if you understand, this is the easiest way of solving it. And this part, you see, R0, R4 is actually solved 3 times. Every time you don't have to solve R0 into R1 into R4. Just R0 into R4 is 1000 fixed, 1000 fixed, 1000 fixed. Just need to multiply with R1, just need to multiply with R2, just need to multiply with R3. That observation is needed. And even for this, if you are here, the leftmost fellow, immediate bottom. Next, 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 next. This is fixed. Only that Ri minus 1 into Rk into Rj need to found. And in that also, Ri minus 1 into Rj is fixed. Only Rk need to be multiplied every time. K varies from where to where? K varies from I to j minus 1. If you understand, done. And that is the answer. So minimum number of multiplications required. We already solved this earlier. In the beginning, I directly given the answer. 2.2k. And now you may ask me, where dynamic programming is used. See, all these fellows, they are already solved, so we are reusing them. See, all these values which are here, they are already solved, we are reusing them. Am I clear? If you don't use dynamic programming approach, every time you have to solve this problem many times. For this problem, you have to solve this. For this problem, you have to solve this. So instead of solving it again and again, we are storing it and reusing it. Am I clear? So that is the basic idea, my dear friends. Hope you understand. And now, of course, you understand A, B, C, D. Minimum number of multiplication is 2.2k. That you understand. That is 2200. But what about the order? For that, see, from 1 to 4, where you cut, at 3 you cut. See, from 1 to 4 you see. Where you cut? At 3. So you cut at 3. Then what you see? It is from 1 to 3 you need to know where to cut. So you see 1, 3. You see 1, 3. Because 1 to 3, no, 1, 3 where you cut? At 1. So you cut at 1. So this is the order in which we need to multiply these 4 matrices to get the minimum number of multiplication and also the product of the 4 matrices, my dear friends. Am I clear? Right. I'll give you one more problem as homework. please write the answer in the comment box, my dear friends. I feel very, very happy if you write your answer in the comments, not in this chat, because I already completed. If you have any doubts, please ask me. The method which I given is the most observational method. I see most of the people solving this problem. They solve every time all this. If you don't observe, you solve it many times, sir. I hardly solve anyone. I just multiplied with R1, R2 because this is fixed. Why to solve so many times? And even these fellows are already available in the table. Just need to identify where are they. I told you now, we just follow this. Here, 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 like that. You can solve any problem like this. So this is your homework problem. Write your answer in the comments. Also, you can write in the comments which topic you want me to discuss, okay, so that I can come up with that particular session, okay. I can discuss engineering mathematics, discrete mathematics, algorithms, C programming and data structures, okay. So these are the topics which already available under BYJU'S Exam Prep app under the category Learn with Video Lessons. Those who purchase can get all these videos. Otherwise also you can see some of these videos. Okay. If you have any doubts, please do ask me, and please write your answer in the comments, sir. I want to see your answers in the comments. Any doubt, please do ask me. Otherwise, I'll be calling it a day. I'm waiting for your final comments. Okay, my dear friends, that's all for today. Thank you for attending my class. Thank you very much. Thank you, sir.